Hello, welcome back to the channel. So let's do a very popular question based on conversion of a sigma notation into a definite integral. So this is one of the most common questions asked in the midterms and exams of first year integral calculus courses. And these are indeed one of the simplest questions as well if you know the approach on how to solve this question. And the approach is very simple as well. So I've written down some steps that you can follow in order to solve this question, and also note that these steps are the most general steps. So these steps can be applied in any question that you solve based on this based on the conversion of this sigma notation into a definite integral. So the steps are pretty simple. They are almost similar to the case when we have to calculate the function fx based on a Riemann sum, but it's just an extension to that process. We'll cover the whole process in detail in order to solve this question and calculate a definite integral out of it. So we'll start with the first step. So the first step is also pretty basic. You have to calculate delta x based on the formula b minus a over n. We'll cover this in detail by solving this question. And you have to find xi, which can be found by using a plus I delta x or a plus I minus 1 delta x based on the convenience, or also based on the question that you see. So if you have an I, you'll most likely use this notation, the right hand Riemann sum. If you have an I minus 1, it will basically give me an idea to use this notation instead of this notation. So now we have covered the first step. We have calculated delta x and xi. Now, in order to solve for the definite integral, you know that in definite integral we have integral fx dx, and we'll solve for these components individually. So whatever you'll get for delta x, every occurrence of delta x will be changed to dx, and every occurrence of xi that you'll calculate in this case will be changed to x. In the same way we changed a Riemann sum into an fx notation in the previous questions. So if you have not watched the previous videos as well, I would highly suggest you to first watch those videos in order to get the full context of what we will be doing in this question. And then this limit, the limit that you see in the question as well, will be changed to the integral sign. So now we have integral, we have fx, we have dx as well. The only thing left is the endpoints a and b. Now in order to solve the endpoints is the trickiest part in this question. In order to solve the endpoints, you basically have to use xi and use the starting value of I and the ending value of I in order to solve a and b. We'll go over this in detail because this is a slightly complex process, so I'll cover this process in detail in the later half of the video. So stay tuned for that as well. Okay, so now let's start solving this question. So we know that our delta x is b minus a over n. My xi is a plus I delta x, and based on this pattern I have to find my delta x. So my delta x in this case would be a term which has n in its denominator, and it should also match with the xi term. So based on both of this information, it gives me an idea that 3 by n, since 3 by n is a term which has n in its denominator, and it also pairs with xi notation because it has an I delta x term, so it gives me an idea that my delta x in this case is most likely 3 over n. So I've identified my delta x, I've identified my xi as well, which is 3I by n, because in this case my a is 0, as I can clearly see from both of those notations as well, just by comparison. So I've compared both of these notations. I found my delta x and I found my xi as well. Now my second step is to convert every occurrence of delta x to dx, change my limit n goes to infinity sigma notation to the integral sign, and I have to change every occurrence of my xi to x. So let's do that. I'll write the sigma notation again. So I have my sigma notation, which is sigma. This is my limit n goes to infinity, sigma I goes from 1 to n, 3 by n, e to the power minus I by n, cos 3I by n. And based on delta x and xi, let's convert all those terms. So this will be changed to the integral sign. 3 by n will be changed to dx in this case because it's delta x, so it will be changed to dx. So my 3 by n becomes dx, e to the power minus I by n. So as I see that my 3I by n should be changed to x, so I can easily divide both sides by 3. which will give me xi by 3 is I by n, right? So I'll change every occurrence of I by n as x by 3 in this case. So let's do that. So it will become e to the power minus x by 3 because I by n is x by 3. My cos 3I by n, since 3I by n is already xi, it will be changed to x. So now I have this integral. I'll write it down again in the definite integral notation. So it will become e to the power minus x by 3 cos x dx, right? Now my only thing which is remaining is the calculation of those endpoints. The calculation of those endpoints which are denoted by a and b. And this is the most important part, because identifying the pattern and extracting delta x and xi and changing all and doing all those conversions is easy, but the endpoints calculation is a bit trickier in most of the questions that you do. So as I said, in order to calculate the endpoints a and b, we'll use xi and we'll use the endpoints of I. So in this case, my endpoint for I are I equals 1 and I equals n. And my xi in this case is 3I by n. So let's do that. So in order to calculate the endpoints, you'll first write xi, which is 3I by n in this case. You'll write the endpoints of I, which are I equals 1 and I equals n, right? And the starting value of I will give you a, and the ending value of I in the sigma notation will give you b. And now what you have to do is you'll calculate xi in both of these cases based on the values that you have for I. So if I have to calculate xi in this case, I'll substitute I equals 1 in this case. If I have to calculate xi in this case, I'll substitute I equals n in this case. So let's do that. Let's calculate xi in both of these cases. So if I calculate xi in this case, which would be done by substituting I equals 1, I'll get 3 by n in this case. And if I do the same process in this case, when my I is equal to 1, I'll get xi as 3n by n, which would be 3. And now the last step is to take limit n tends to infinity on both sides. So if I take limit n tends to infinity for 3 by n and limit n tends to infinity for my 3 in this case, I'll get my a. So this will be my a and this will be my b in this case. And now I can clearly use limits, since 3 by n when n tends to infinity approaches to 0, I see my a is equal to 0, and since limit n tends to infinity 3, which is a constant, it will remain a constant, so I'll get my b as 3. So now I got all the components of my definite integral. I'll write my definite integral, which will be my final answer, which is integral x goes from 0 to 3. My function was e to the power minus x by 3 cos x dx. And this is my final answer. This is what I'll get if I convert this sigma notation into a definite integral. So that was it for today's video. I know it's a complex process, and we'll do another example in the upcoming video in order to reinforce this concept. But the advantage of using this process is that it is the most general process that you can apply in almost every question of this type. So whatever question you'll get, you can follow these steps in order to convert your sigma notation into a definite integral very easily, if you know how to follow these steps. I know in some scenarios you'll not need to go through the whole process in order to calculate the endpoints, because sometimes the endpoints are clearly visible based on the notations that you have. And you can also take the example of this question as well, because if I had to solve this question by only using comparisons, I can easily see that based on this xi and this notations, I can see that my a is equal to 0, because xi is 3I by n, which can also be compared to a plus I delta x, and this gives me an idea that my a is indeed 0. So if I were to do it another way, I would have taken a to be 0, and since I knew that my delta x was b minus a over n, my delta x would become b over n, which can be equated to 3 by n in this case. So b over n is 3 over n, which would have given me my right endpoint as well. So even if you'll follow through the comparison process only, you'll get the final answer, you'll get the correct endpoints, but I wanted to guide you through these steps, which can be generally applied to almost all the scenarios in which you have to convert a sigma notation into a definite integral. So this video was focused more on guiding you through a general approach on how you can solve such type of questions, but if sometimes comparisons make your calculations easier, feel free to attempt that process instead of following through the steps. But if you get stuck in solving these type of questions, you can always rely on these steps in order to get to the final answer. So now let's wrap up this video. I hope you found this video informative. Feel free to comment down in the video if you have any doubts related to this video, and we'll cover one more example in the upcoming video in order to solidify the concept that we learned in this video. Thank you so much for watching. Stay tuned. Bye bye.